go ahead and get started now. A little bit about my background as far as photo rendering goes. I've been rendering inside SolidWorks for a long time. I started using PhotoWorks, if anyone remembers that. That was back in like 2007. And then I learned Photo View when that came out, Photo View 360, which still exists, still there today. And now we also have SolidWorks Visualize, which is our newest, most high-tech renderer. And we're going to talk a little bit about in this presentation why, what's so great about that new technology. But we're also just going to talk about a lot of tips and tricks for, this is considered, I'm calling it a tips and tricks like advanced webinar, and it is good for somebody who's, I'd say it's good for somebody who's already tried to play around with Visualize. So if you're brand new to it, this might not be the right webinar. It's not going to give you like a high-level overview of it. We're going to be really diving into like import settings and things to be aware of when bringing over files. So kind of as to make sure this is the right presentation for you, here's our agenda. I'm going to focus quite a bit on the import structure available. So when you export your model from SolidWorks or import it into Visualize, the different options that are there, and what can make them useful. We'll spend a little bit of tiny amount of time on making the render actually look good. Again, this might not be the best webinar for that. It's more about what I want to show you is how to prevent like performance issues, how to really set up the best workflow to bring in large models, or just avoid some of the difficulty that you might have as a new user going into this. I should also mention we have a brand new training course that's going to be taught for the first time very soon on SolidWorks Visualize. So if you've been self-taught using it, we now have a course from SolidWorks that we'll be offering. I think I can send you the time for the first online course if you're interested in signing up for that. So these are the things, at first we'll be focusing on the import settings and things like that, and it's kind of streamlining your workflow, things you can do in SolidWorks, quite a few things you can do in SolidWorks to make your life easier in Visualize once you get to the actual render. And then also some background on what how Visualize works and the graphics card hardware that it can run on and things to reduce the burden on those graphics cards. So that's kind of the way we have it structured here. Hopefully it'd be helpful for everybody. So the first thing I want to talk about is the way we move our model from SolidWorks to Visualize. So if you're running standalone Visualize, you'll just be opening the SolidWorks models. But if you're within SolidWorks, you do have access to this Visualize add-in that allows you to export the model, basically pushes it out to Visualize. There's two real options there, Export Simple and Export Advanced. And I'll try to clarify what those two do. Okay, to understand that, we're going to have to understand the different grouping methods that are available in SolidWorks Visualize, our photo renderer. Basically what the Export Simple function does is it groups everything by appearances. So what that means is very easy to change colors. If I have an assembly where everything is red, say a bunch of components are red, if I just drag a new color on it inside Visualize, all those red parts will change to green, for instance. So very easy to change colors. It also results in the lowest part count inside Visualize, lowest amount of like individual things that are being resolved. So it tends to have the best performance. That being said, because it groups things a certain way, if you're trying to make like an animation in Visualize Professional, or you're trying to, I call it posing the model, just moving it to a new orientation, moving components around, maybe creating an exploded view, then Export Simple will not be the right method for you. You'll probably want to use the Export Advanced. That uses what's called automatic grouping, basically keeps all the parts separate more or less. Okay, so they're separate things you can select. So it's more tedious to apply a bunch of colors, but at the same time you have more control. You can manipulate things around easier, individual bodies, and it still has good performance. So we'll get into this in a practical example. Here's what the difference will look like physically, what you see in the tree in Visualize when you import with Simple in the top left there, where you have the root folder and you just have everything grouped by color underneath it. And then with the advanced option, you have all those components individually selectable and resolved. This corresponds, if you're within Visualize opening things, then this corresponds to if you use the appearance grouping, is basically what Simple is doing. And if you use the automatic grouping, is what Advanced is doing. So we'll take a look at that. Let's look at that on this robot arm example here. And my objective here is to create a really simple project, something that once the Visualize project is set up, anyone will be able to go in and drag and drop in colors and change things really easily. Not necessarily that I'm trying to create like a posable model and move it around. So for that purpose, the simple export works very well. And I'll show you again some of the tips within SOLIDWORKS that we'll use to prepare the model. So here I am within SOLIDWORKS. I have the Visualize add-in loaded up. You can access it through your SOLIDWORKS add-ins page here. And basically the idea behind the simple export is, again, whatever colors I have applied to bodies, when I export, they'll all be selectable as individual things within Visualize. Now we'll get towards how to make this actually look good in Visualize as well. But basically what this allows you to do is you can basically group the components by color. So say I want, for some reason, I think maybe I do want to change this middle arm, the color of it, to be different. Then I would want to drag some kind of different color on there within SOLIDWORKS and apply it. Okay, then that would bring it in as a separate item. So if I wanted to make that different color, I could change it afterwards. If I'm sure all these red components are always going to stay the same color, then I can leave them grouped like this. And basically I'll just click Export Simple, which is going to launch Visualize, bring in a new Visualize project with the appearance grouping options. Okay. By the way, this webinar will be posted on our website. It's being recorded, so it will be posted on our website after this broadcast ends. So if you need to get going early, anything like that, you'll be able to. And Visualize just popping up on my other screen here. So give me one moment to bring it over. We're going to be doing a little bit of back and forth like this between the software. So let me go to preview mode and Visualize. This is just quick so I can just rotate around without actually doing real-time rendering. And we'll look at the component structure that was brought in. Visualize terminology, we have what we call model, we have part, and we have group. So those are kind of our hierarchy, model, part, group, and you have selection filters based on that. So you'll see, what we should see is that basically everything's grouped by material, right? There's a whole bunch of parts that are going to be grouped. If I find that candy apple red color and go to my part selection, we'll see that all those parts highlight. They're all grouped by that material. I can click on brushed steel and see all the brushed steel materials. So what this means for me is if I need to change the color, I can go to my appearance library. So the top right option here, find a different color I like, drag it on. You see all those components update, right? So this is why the appearance grouping is nice. Makes it very easy for me to quickly test different configurations of the product, different color schemes, without having to apply them a whole bunch of times to individual bodies. Okay. Now there's grouping you can manually do to accomplish the same thing, but that's one of the nice benefits of the simple appearance grouping option. Okay. So hopefully that's clear. The downside of the appearance grouping is if I go to select anything, say I want to translate one of these arms or rotate them, I really can't. They're all grouped together. So if I go to translate something, I can't move just one arm individually. It pulls the whole unit, right? So we could do extra work to split those out, but if there's any chance you're going to want to manipulate the model, this is what I meant earlier when I was saying if you want to make an exploded view or do something else, then you probably want to be using the advanced export to bring in all the individual components. Okay, so that's kind of the basic premise there. Now, one of the problems with this is that in SOLIDWORKS, it's hardly ever the same appearance applied to the part everywhere. Like that's what makes this function really nice. So I can just drag and drop in an appearance that changes everything. That will hardly be the case when you try this with your SOLIDWORKS model, because in SOLIDWORKS appearances get applied over and over and over, and no one really pays attention to the appearance hierarchy. So if we look here at this arm I have in SOLIDWORKS, I would click on the little display manager beach ball, and I can look at all the appearances that are applied here. Now I've already cleaned this one up. There will be some you see that will not be this clean. And actually this is, you see how I have multiples of the same appearance name over and over. Again, what I find in practice is you end up with like color, just so many colors dragged over each other. It doesn't really help that when you place an appearance, when I go to place an appearance in SolidWorks, we have to choose this hierarchy, and it can be confusing. Like if I place it at the part level, it's actually going to get overridden. So even though that appearance is there, I don't actually see it because I have another appearance that's at a higher hierarchy. Right? SolidWorks has this whole hierarchy of where the appearances can be applied. You know, bodies, features, faces, assembly parts. So if you've done rendering before in SolidWorks, you'll be aware of this. It can be frustrating because I'll be like, why isn't this appearance taking effect? Let me try to edit it. And you can be like, you might have two red colors and you're trying to adjust the brightness of them and they're not, one's not working, right? It's just frustrating. So if I have a really messy model with appearances all over, usually what I'll do is use this trick where I go back over to SolidWorks. And this is really, you could do this for any reason, even if it's just a regular SolidWorks model or photo view rendering or anything you want to do. If you want to just clear out the appearances, you expand this little arrow and you click the little beach ball icon next to the assembly name, and there's an option to remove all appearances. Remove all appearances from the robot. Now it's completely blank. There's nothing there. I can start with a clean slate rather than trying to have to go through and delete all the duplicates. So this is the way I would set up a model if you're worried about using this export simple appearance. If I'm planning on overriding all the appearances in Visualize anyway, then I probably shouldn't go through this effort. I could just export the plain model with the advanced option, which will bring them all in as individual components, and I could apply all the individual appearances. Okay. But this is nice if you want to clean up your SolidWorks hierarchy, and especially if you're going to be using that export simple option. Now I can grab the appearance I'm interested in, drag and drop it in. Another little trick for applying these is you can click this little pin icon here. So rather than having to use that pop-up all the time, you can click the pin icon, and you see I accidentally did apply one on a face there. I'll clear that off in a second. But now that that's defined, I can apply it. In this case, I'm applying to bodies because there's some multi-body parts here. So I basically need to apply it to bodies. And this is how I'm dragging in. So all those are assigned. If I look at the actual name, they don't technically group in under one appearance, but that's okay. As long as they're identical appearances, they should get grouped together in Visualize. Okay. So that's the general idea. You could copy and paste. You could try to apply. If you apply at the assembly level, you can actually apply appearances to multiple parts at once. That works too. But basically, this is the idea: is you want anything that you might want to be separate. Maybe the base down here will be brushed steel, and then other stuff I want to make out of chrome. I just separate those appearances, and I'm building a really nice, clean history here. So the rest, maybe these other parts are polished steel. Right, building a nice, clean appearance. So there's a little bit of prep work that you put in will be really helpful when you go to actually do your renders, right? And maybe all these things will be the same. These metal caps, and then the last thing I'll use is some plastic. Okay. So get all that set up and then place some plastic on the motor units. Also, certain appearances just look better than others. Like if you're doing plastic, I find these textured plastics look really good. That being said, I'll usually end up replacing most of the plastics, most of the textures from SolidWorks, because the ones in Visualize just look better. They're newer. You know, a lot of these materials were created not necessarily with photo rendering in mind. So, but this is basically the setup process. Now I've got all this nice clean appearance library, and I would have a similar result to what we had initially. Okay. Some other prep work, since we're kind of on the topic, some other prep work you can do in SolidWorks is you can set up camera views. So it's nice to have a camera view set up so you can get that same exact camera angle again and reference it if you ever need to. And basically, if you click on this other tab in SolidWorks, the little cameras there, you can expand out. I already have one created, but say I add another one, I just click Add a Camera. And again, this is the same process you'd use for PhotoView 360, but the cameras do carry over to Visualize. So if I someone asked the question, if you remove all the appearances in the assembly, does that also remove the appearances in the part? And it does. To use that override the way I did, it stripped the part appearances, which may or may not be appropriate, right? If you're in a controlled vault environment, you don't want to be modifying all those files. But usually for Visualize, I end up making a copy of the files or something like that and working on it, because you probably want to create configurations to pose the model in different ways. So let me clarify that. Yes, there's two different ways to do this. If you click in here, this removes all, it actually says removes all appearances from all components. So it strips all the parts. You can see all the individual parts were sent back to their gray color. If you, there's another option, I'll have to see if I can find where it is, but it just strips the top level appearances. There's another option available that only strips top level. I forget if it's in the hierarchy. So I apologize, I don't remember where it is off the top of my head, but there is a option that will only strip components. So only strip like the assembly overrides. Okay, so you can do it either way, but this one I'm using here strips all appearances from all the components. It actually does reach down and strip them all. Good question. So I was talking about creating camera views. We come over here, right click, add a camera, and then there's different ways you can do it. You can actually try to manipulate using like coordinates here of the camera. But usually what I do is I go into this right selection box and I just rotate my view until I get the angle I'm interested in. And control your zoom. It might be nice to do shift, the middle mouse button, so you can do the really smooth zoom here and pan. And then you also want to adjust your perspective. So down here, one of the reasons we use these cameras is because we can actually adjust perspective. So if you want that really exaggerated wide angle look, you can set that here. There's different presets for different things. This can also be adjusted in Visualize, but if you're a longtime SOLIDWORKS user, it might be easier for you to do here, right? And once I have that set up, click the check mark, now I have cameras created. So when I hit my spacebar in SOLIDWORKS, I can always access those camera views and basically get a preview of what my render pose is going to look like. I can, it'll be locked while you're in here, so you have to go to some other type of view to get out of that. Okay. The other thing that's really easy to do in SOLIDWORKS is applying decals. So down here I have a decal applied. The type of decal mapping SOLIDWORKS allows you to do is this label mapping, which is really nice. When you apply to just the face, lets you do this label mapping, which works really nicely. Actually looks like it's stretching the label out there. And currently this is just easier to do in SOLIDWORKS, and the labels map over really nicely to Visualize. So this was not always the case. I think when Visualize first came out in 2016, it did not support, it didn't have as good of a decal transfer. And now it's doing a really nice job mapping over these decals. So if you have a complex decal like that, I do recommend placing it in SOLIDWORKS first if you have that option. There's things you can do to place it in Visualize as well. Okay. So that's kind of the initial prep work I would do in SOLIDWORKS to set it up before I do the export to Visualize. Okay. Now let me see if I have already, I think I have a starting version of this that we can open up. Let me just make sure it's set up correctly. Yep. So now let's talk about how to actually make the render look good. Because one of the problems is when you first bring a model into Visualize, typically you're going to be, maybe it'll look great, but usually people are somewhat disappointed. They turn on the display and they're like, you know, it looks nice, but this is real rendering now. It's not quite as eye-popping as you might want it to be. And honestly, a lot of the problem is the SOLIDWORKS appearances and the SOLIDWORKS environment. So it's great that those got carried over, but again, those environments and appearances weren't really made. They were made. Some of them might have been made back in 1996. They didn't have photo rendering in mind. So one of the first things I'll want to do in here is change my environment and override some of the appearances. So inside Visualize, now Visualize gets its lighting from these things called HDRI images. They're basically things I can activate, and they change the whole lighting scheme here. And it can be tough to tell until you change both the appearances and the environment. It can be tough to know if you really made a positive change. But here I know I like this high contrast environment. I don't like the back plate that's behind us. We'll change that in a second. It's basically just an image. But you'll see here when I'm saying environment, it's separate from what we're actually seeing behind the robot. The environment here is controlling all the lighting on it. And we want to get most of our lighting, like 95% of our lighting for a product render like this, we want to get from the environment. We don't want to spend time, if you have Visualize Professional, it lets you create lights, but the second you start adding lights here, your complexity goes way up. What you can do if you need to adjust the lighting is you can download these different environments. There's many more. You can access the cloud library and access a lot more, or you can find free HDRI light maps online and pull them in. Okay. So before I make any changes, I'm going to add appearances. I'm going to override the SolidWorks red with the Visualize red. I'm going to go into Paints and choose this candy apple paint and drag it on. You'll see it's much more vibrant right away, right? That one little change, if you notice that. So even though something might be red, I usually end up replacing it, remapping it with the visualized appearance, because again, these appearances, they're not just the color, they have a lot of information built into them about the glossiness and specularity and all these advanced features that you can build in. Some of them are even multi-layered, like metal flake and all kinds of cool things. But it's nice, the simple setup makes one drag and drop to change all those, right? If I want to change the legs, even though it's set as a metal in SolidWorks, I might want to change it to something else here. Maybe it's going to be chrome. Drag and drop down. Now in this case, it's just, I think the appearance is just too dark. Maybe drag down brushed aluminum. That works a little nicer. So all of a sudden, I'm a lot happier with what I see. So now let me go back a little bit. I got the appearances a little bit better. Now let me go back, look at the environment again. And this time I'm not modifying mine. I'm not going to replace the environment. I'm going to modify it. If I click on my Scenes tab, the number one thing I try to adjust is my environment rotation. This changes. If you drag it, you can kind of see, and by the way, these real-time previews are just so great. You can see the adjustment in the lighting because I'm basically spinning the room around this robot. So I find the angle I like and leave it there. Now I've got a lot of nice contrast gleams on the robot in different places. And again, this is just a rendering preview here. I can also access that camera view I brought in. If I go over to it, I don't know if this one had it mapped over, but if I click on that camera view, it'll bring me to that exact orientation I had. And probably what I would want to do is lock that camera view. Lock it, that way I can't accidentally override it. Okay. So again, I can still see areas where the materials should be, replaced or beefed up, but I'm much happier already with the result. The thing I really don't like to see is the SolidWorks background. That's actually the back plate here. So if you go to plates, there's different back plates. So like the studio back plates look much, much better than some of the default ones that are available, right? So you can choose from these different backplates, or you might turn off the backplate altogether and render out just the image itself. The backplate doesn't affect the lighting on here. It's just the background. So you can go into your options, select your backplate and just disable it if you just want to see the model in space. Okay. I'm using also the new denoiser here. This is a new option. This works great. If I turn off this denoiser, this makes it render so much faster. You'll see how grainy the legs look. For instance, when I rotate, there's a graininess because the brush material takes a while to resolve, many render passes. And when I turn on the denoiser, it just skips that process. It's pretty amazing what it's doing. So you can get really nice renders with a lot less number of passes by turning on this denoiser. Okay. So that's a general idea. With Visualize Professional, one of the cool things you can do is you can add multiple configurations. You can add another configuration here if I want to have an alternate appearance, right? If I want to mix in different color. And now it's so simple, someone can just swap between these different configurations to see the different colors. Okay, so those are all options. We could get this to look much nicer again by replacing the remainder of the materials, replacing the things that look very plasticky right now, replace those with like the Visualize plastic. It's going to look better than the built-in SolidWorks one. And Visualize allows you to build your own materials, so you can do really cool stuff if you're comfortable with Photoshop and all that. You can, like, this looks like a much more realistic textured plastic to me if I drag these on. you can do a lot of material work inside Visualize. Okay. So that's really the bulk of what I want to show in this example. Okay, quite a few different tips there. But the key thing to remember with simple mode is not good if we want to manipulate the geometry. It's great if we just want to change colors, move things around. Okay. Let's go back to preview mode here so I can give my laptop a rest. I'm not running this on any crazy hardware, by the way. It's just a Dell Precision laptop. It does have a Quadro graphics card in it. Not one of the really high-end ones, just the entry-level one. So we'll go more into the specifics of what makes Visualize run fast. We'll talk about that later on. So summarize here the tips we used. We did do the remove all appearances from all the assembly. To clear that out, we manually defined new appearances using the pin to speed up the process. So we could set up that nice simple grouping. We created a camera in SOLIDWORKS so we didn't have to try to find the ideal camera angle in Visualize. And I applied whatever decals I wanted in SOLIDWORKS. Those are just some general tips. Again, you don't have to use those, but to me, they make my life easier because I have the strong SOLIDWORKS background. Okay. As far as making the render look nice, definitely use the Visualize environments and materials. So the first thing I try to do is replace those. And just don't go too crazy. You want to get it kind of in stages, right? First is like get it baseline, adjust the environment brightness, environment rotation until you're mostly happy with how it looks. And then if you want to go and add an extra spotlight or something, do that. But just take it in steps, bring it in, assign the right materials, assign the new environment, adjust perspective. If you have Visualize Professional, the depth of field effect is really nice to add those post-processing type effects, depth of field and bloom lighting and things like that. So here's another example. This one, say I do want to be able to manipulate it in Visualize. Maybe you don't have access to a copy of SOLIDWORKS. You're just doing renders. You only have access to Visualize right now. Then I would import using the automatic option in Visualize, or it's called the advanced option when you're exporting out of SOLIDWORKS. Okay. So let's look at that example. Then we're going to just cover some back-end stuff about what's actually going on, how Visualize works. Let me see if I have one of these already. I might have one of these. Yeah, this one. Let me just do a fresh export. It might take a minute, but this was actually set up from a photo view rendering. I had a camera and everything already set up. So I'll do export advanced, which is, it's going to think for a while because it's a big assembly, bigger assembly. And then if we look at my assembly tree here, if I expand out, I should have the root folder, and now instead of everything having an appearance name, it actually has the file name, right? So I actually have individual parts I can select, and this is useful if I do need to accomplish motion. Now, I would always recommend, SOLIDWORKS has mates set up, so if your mates are already set up for the motion, it's easier to just pose the model in SOLIDWORKS and then export it. But again, sometimes you're in a pinch, you need to make some changes, or maybe you're going to be doing an exploded view, you're going to be manually pulling things apart in here, even though, again, if you have Visualize Professional, it'll even pull over your motion studies. So if you do an exploded animation in SOLIDWORKS, it'll pull in here. But let's just suppose I want to make a change. So I'll go to my group selection, and you see now I can select just the lid there. I'm in preview mode, so it's not rendering right now. But I can select my components. I'm interested in working together, and there's no mates in here, so you have to manually kind of transform things. But you can make it easier by selecting these, and I can right-click and add them to a new group. So move them to a new group, and this is basically like a selectable group of entities. Call this my upper lid, and maybe I want to see it closed. So now I select that upper lid group, and this is our transform tool. If I go to translate, by default, it's going to have the wrong rotation pivot. So if I try to rotate, not going to do what I want. But the nice thing is I can move that pivot, and I only need to move it once for that group. Now, when I select that group again, once I adjust this pivot, it'll rotate about the correct axis. What I tend to like to do is I'm in like a high perspective view right now. So really I want to move to like a no perspective view or very low perspective to be able to manipulate that pivot. It just makes my life a little easier. Okay. So this is one of the functions that's available if you're using the other import options. Right now I can close the lid. It might not be 100% mathematically perfect, but you know, for photo rendering, it's going to be enough to fool anybody. And if I ever need to open the lid again, I just click on it, activate my transform tool, and it should that widget should show back up with the same options to rotate. About the correct pivot, you can see it bounced back there to rotate about the correct point. So I never need to redefine it again. And then we go through the same process on this one. We would, you know, choose a nice camera view that I'll lock, go into rendering mode, right? So I can actually start to see a preview of what it's going to look like, and then start redefining appearances and materials. Because again, these were set up, might have looked nice in photo view, but these materials are going to work a lot better in here. Even just simple things as paint. You can see the difference there up top between the Visualize nice black paint and the kind of faded out one from SOLIDWORKS. So just repeat that process. And again, these real-time previews, this is my favorite thing with Visualize because it is GPU accelerated, which we'll get into more what that means. I get these such quick real-time previews, and this is really quite slow on my laptop compared to, like, I have a home computer with a much higher end graphics card, and that just flies. So you can get almost a full HD preview on here as you're working. And all the CPU-based renderers I've used is great if they have previews, but they're just kind of sluggish and they make me not want to use them as much. So that's probably my favorite thing about working with this, is that I can see more or less real time all the changes I'm making. And it makes that fine-tuning process a lot easier. To answer the question, someone had a question on the pivot snapping. Was it snapped to the correct place, or did I place it manually? I placed it manually. There is an option. What you can do is, if I'm using the pivot set to, like, say, the center of a bunch of components, you can move it to the center of an individual component. So there's an option there to use the pivot center of a component. Sometimes that works great. If it's like a bolt or something you have selected, you set the pivot center to the center of that bolt, boom. That's great because that's your axis of rotation. So there are options like that that you can use, but a lot of the time when I'm doing this stuff, it's getting it to look close enough so I don't have it completely dialed in. So this is another quick example. This one, again, made better use of the simple export, but then you see I have to define all the materials individually. I had to drag and drop in on each of these pieces individually, change the color. Okay. All right, so I want to go into some of the back end. This is kind of the more advanced stuff that I actually want to talk about with this presentation. If you look down here, you'll see this polygon count, 316,000. That's a number that I want people to be thinking about as we begin to talk about how Visualize works. So Visualize, let me just turn off my render mode here, yeah, and close this down for now. Visualize is a GPU-based rendering engine. So it can run just on your CPU, but you won't really be getting the best experience out of Visualize. You really want a decent NVIDIA graphics card. And it has to be NVIDIA because Visualize uses CUDA, which is NVIDIA's GPU acceleration technology, GPU compute. It's actually based on what's called the NVIDIA iRay engine. And this is something I feel like we don't really express enough to people, that really, you know, if you're building a system to render, or even if you just think you want to be doing some rendering on it, your experience is going to be so much better if you invest in like a decent NVIDIA graphics card. Because you can see CPUs there works, right? But great, but look at the performance scaling if you go towards the higher end graphics cards. Like, it's literally up to 20 times faster in some cases over just CPU-based rendering. So on my system, I'm running it with just a lowly Quadro M1200. So SolidWorks has some great tabulated benchmarks. I have the link there. If you just search SolidWorks Visualize benchmarks, you'll find that as well. You know, the officially supported card is the Quadro for SolidWorks, but we've also seen a lot of customers using GeForce cards as well, the entry level, you know, the consumer level cards that are maybe, you know, wouldn't be officially supported for SolidWorks use, but basically the CUDA cores, the CUDA processing is the CUDA processing for NVIDIA. So you can also find there's some third-party like system builders, Puget Systems did some great benchmarks with the consumer cards if you're interested in that. So if you're building a machine just for Visualize, that's another option for you. So the performance scaling with the graphics cards are huge, and if you want to get, you know, good render performance, I think the sweet spot is at least one, you know, mid-range NVIDIA graphics card. If you can afford to get multiple high-end graphics cards, it will reward you with the decrease in render time. So that's the big new technology that's you know, the reason Visualize is there now and why we don't just have PhotoView, because PhotoView will always be CPU based and kind of more limited in its performance scaling. We can't even do clusters of computers with Visualize Professional and Visualize Boost. So if you want to set up multiple, you know, it just keeps going, the performance scaling. If you want to set up multiple machines with many graphics cards in them. But one thing to be aware of is these features like the GPU acceleration requires the project, the render, to fit into the graphics card RAM. So graphics cards have their own RAM called VRAM. That's actually one of the differences you'll see between the GeForce cards here and the Quadro cards. I don't think it lists the VRAM on those, but a lot of times the Quadros will have like twice as much VRAM as the GeForce, or, you know, a little bit more at least. That ultimately controls how large of a complex scene you can render, the VRAM. Because if you exceed your VRAM, RAM's, I always tell customers with anything SolidWorks, Visualize, RAM's never a problem until it is. So you could be, if you have 8 gigs of RAM and you're using 7, you're never going to know that you're close to, you know, hitting the limit. But the second you go over 8, your performance is just going to take a nosedive, right? And we get that same experience in Visualize with the video RAM, VRAM. So if your project is so close in size to maxing out your RAM, eventually you see that it's going to switch over to like CPU only mode, and your performance is going to go way, way down. So the correlation we have there is what's called the Polygon count in Visualize. That's the closest thing we can use to predict how much VRAM it's going to need. And it's not like a lot of budgeting you need to do. I think the ratio, the rule of thumb is like every 1 gigabyte of VRAM gets you like 5 million polygons, which is a lot. But there's other things in the scene that can add more complexity and reduce that. So it's just something we want to pay attention to. I wanted to show everyone how you can monitor if your graphics card is being used by Visualize and how much. So Windows 10, if you have Windows 10, the task manager itself will do that. You bring up the task manager, you can actually click on your graphics card and you'll be able to see how much is being used and the memory usage right here of how much memory the graphics card is being used. If you older system, Windows 7, there's a free utility you can download called GPU-Z, third-party utility, you know, unaffiliated, but it's a nice tool for diagnosing graphics card things, and it will show you GPU load and memory usage. So you can just make sure, confirm that, you know, maybe your Visualize is running slower than you think. You can confirm with any of these tools that it's actually using the graphics card the way it should. So I just want to pay attention to what can max out the VRAM. And the main thing is the number of polygons, like I mentioned. And what I wanted to point out is when you're exporting from SolidWorks, there's one big thing that's controlling the polygon count, and it's your image quality. Okay, your image quality settings in SolidWorks actually control the tessellation, how the model. It's basically like a mesh that's getting brought into Visualize, a mesh model of the geometry. It's not real solid geometry. So here you can see the same exact file. If I had the image quality all the way cranked up, really simple assembly, it's over 1 million polygons, right? Which isn't bad. Just renders fine on my system. But if I lower the image quality, it goes down to like a few thousand polygons, right? So your spectrum there is massive over how the image quality affects the rendering performance. And so I just want to point this out quickly here. The other thing you can do is if there's components that are hidden, internal, that you're never going to see in the render anyway, you might consider just suppressing those components, not importing them. So this is on the bare bones image quality. You see, if I look, you get that octagonal looking, polygon looking circles and things. This is literally the image quality ranked all the way down, which is not necessarily what you want to do, right? But if I push this out to visualize, we'll see only 4,500 polygons, right? Very low polygon count. If we were to go into SOLIDWORKS and crank that image quality all the way up, of course, we would see much more refinement. So in SOLIDWORKS, when you're in an assembly, there's an important option also here. This can cause mysterious behavior. Apply to all referenced part documents. So right now, if I apply this image quality, it's going to apply to all the parts, not just the assembly. So it's a little bit tricky to think about. Okay, so say I do that, all of a sudden everything's going to look really nice, smooth. But if I redo my export, if it's a big assembly, this is going to potentially push you over that edge of, now here in this case, 350,000 polygons, right? 5,000 to 350,000, almost 100 times more. So the neat thing is you don't have to globally toggle that. Okay, so getting into a little more advanced tips and tricks, you don't have to globally toggle that because assemblies, the individual parts can have individual image qualities. So let's say I go in and I decrease my image quality on the global assembly to pretty low, but then I open up this part on its own and I increase the image quality on it. Okay, I increase the image quality on just that part, and I go back here and I open up another part on its own, the wheels, the big circles that you're going to be seeing a lot, right? Increase the image quality on those respectively. And now I have like a hybrid image quality setup. I have high polygon count on the two circles, but lower polygon count everywhere else. So if I export, I should have somewhere in between the two. I think we were from 5,000 to 400,000. Now we're at 16,000, right? So we've got a best of both worlds where I have really smooth circle down here. At least I think that's the one I opened. And then elsewhere, you know, if you zoom in, you start to see the jaggy nature of things. So you can control kind of on a hybrid basis, part by part, image quality settings when exporting over to visualize. Good question from James here. Is the image quality, missed part of it, just why are we reducing image quality? Simply to stay under the VRAM limit. Yeah, so I wouldn't bother reducing this unless you were seeing performance issues, right? If you're seeing performance issues, then you want to pay more attention to reducing your image quality. But as you see, millions of polygons are fine. Don't cause issues until you get to that limit where all of a sudden now you're running out of memory. There's other things too, like the denoiser tool. So when you're going to render, the denoiser tool also turns off at a certain limit. If the scene is too complex, you won't be able to use the denoiser. So that might make the threshold a little bit lower than you're used to, where if you all of a sudden see the denoiser is not working, you might want to try reducing the polygon count a little bit, and then it may be able to kick back on again with your current hardware. Because that's, you know, using the graphics card as well. The graphics card's for rendering, and there's also the denoisers trying to remove all that noise using the same graphics card. So they're kind of over limited resources there. So that's a good reason to have some extra overhead in your hardware if you want to be using the denoiser tool. So yeah, this is just to avoid, this is a really simple example, but really you'd be applying these techniques on large complex scenes where you're running into performance problems. Okay. The other option that can cause performance problems is if you're manually importing into Visualize, if you're doing a file open and say you're browsing out for a SOLIDWORKS file, let me think of a file to open here. I'll just open that grill, for instance, that we were looking at before, and I open a SOLIDWORKS assembly. Full grill assembly. So this is not pushing from SOLIDWORKS, this is the manual import process. you get this option. So this is what I'm saying here. Basically, if you choose appearance, that's going to be very similar to the simple export, where it's going to group all the parts together by appearance. If you choose automatic, it's going to basically keep each of those parts separate. If you choose retain structure, it keeps the actual assembly structure, but the problem here is it brings in like each face split separately. So that's something we can split up faces if we want to, but if you choose retain structure, you're going to be performance hurting for a different reason, where you have basically thousands and thousands of extra faces, objects within Visualize, basically parts that you don't necessarily need. So I highly advise against using the retain structure. It's tempting because it keeps the feature tree the same essentially. It can be nice on a small example if your system can handle it, but odds are your general performance, just like rotating the screen around, even in preview mode or something with the retain structure on, is going to be quite a bit worse. And I realize it probably doesn't come across on the GoToMeeting, but when I'm rotating this, it's much less smooth than it was with the other import methods. And that's strictly because if we look at any of the components in here, similar to automatic mode, it brings over all the parts, except then they're all ultimately divided down into faces. There's like individual faces here. So I've seen people choose that option, kind of not knowing what it does, and it will really bog down performance. So it doesn't show up in the polygon count, but it's just there's a lot of overhead because look at all the faces in just one body that are being isolated as separate parts essentially. So I'd advise everyone to never use retain structure except on a very simple example that they're sure their system can handle. The appearance grouping, if you want to group the appearances, or the automatic if you want the ability to select them individually. So yeah, we said we can selectively adjust image quality if we need to. The only other option I wanted to go over is if you're bringing in and imported a step file, neutral CAD file, then you have the option to control the tessellation on the import. So when you're bringing it in from SOLIDWORKS, that tessellation is already stored in the SOLIDWORKS model. We can't really adjust it unless you go into SOLIDWORKS and adjust the image quality. But when you're importing a third-party neutral CAD file, if I do a file open and browse, I think I have one on my desktop for a step file. If I go to open that up, then I get to adjust on import my tessellation quality right here. Global adjustment. So just be aware of that. That, again, if you max this out, you might be getting into a high polygon count. Okay, so it's just something else to be aware of when you're mixing sources from different CAD files. So that's really the content I had prepared for today. Hopefully some of these tips were helpful. I know we started off basically covering the import process from SOLIDWORKS, exporting the model in a simple way where we did the appearance grouping. And we looked at some of the things you can do in SOLIDWORKS, like defining your cameras, decals, appearances, to streamline your workflow and Visualize. We kind of compared those simple and advanced options to where if you want to adjust, move the model and Visualize, you want to be using the advanced export or the automatic grouping, it's called when you do it from Visualize. Automatic grouping on this end. I'll just kind of, I guess, go back to my first slide here to recap quickly. We talked about some things to do to make your render look better, right? Using as a rough starting point, at least, use the Visualize appearances in an environment rather than your inherited ones from SOLIDWORKS. On the high end, of course, you create your own textures, your own appearances and environments. We talked about the rendering engine, the GPU scaling that's there, and basically how you just want to make sure your scene fits within the video RAM on your graphics card. You can use just the task manager to check that, or GPU-Z as a utility you can use to check that. And importing third-party files, be sure to pay attention to the tessellation quality. So I just want to thank everyone for attending. That's about all I had, again, for content here. We'll keep it open for questions, any other questions that might come through. I'm also curious if anyone has suggestions on additional content you'd like to see as far as if it's more about making the renders look pretty or more of this diagnosing performance problems, what type of content you'd like to see. I guess I'll give another reminder again that we do have a training course now for SOLIDWORKS Visualize. So if this type of thing was helpful, I think you'd definitely benefit from the training course. Great, yeah, we're getting some good feedback there. Some people are suggesting just the learning resources, what are available. So I'll send that information to you. There is a great, actually on my SolidWorks, if you use that website, mysolidworks.com, it's like SolidWorks' own library. There's a great getting started series of videos that are free for Visualize. It's a good thing to get started with. Beyond that, we at Hawk Ridge will be having the class, first class running in a month or two here. I can send you the information on that. And on YouTube, of course, there's a lot of great resources. But we are seeing requests on lighting and environment and adjusting cameras. I think those would be great topics. Maybe if we do a part 2 of this series, I definitely want to cover more on lighting and also on custom appearances and textures. So I think we'll kind of think of that as a advanced follow-up to this. In Visualize, you can adjust the cameras definitely as far as their placement and perspective and depth of field, but all the lighting and shadowing effects are basically due to your lighting in the scene. So it could be the environment, the HDRI environment, or it could be point lights, spotlights that you have set up, area lights, any of those things. Let me just show here the My SolidWorks thing I'm talking about. It looks like this. So Visualize lesson, it's called. There should be like 12 parts, and it really does a pretty good job going through the basics, at least to get you started. It's like a nice set of tutorials. So that's something you can access. That's free as long as you make the My SolidWorks account. It's not like a full training course. It's just a set of tutorial videos. And then we also, of course, have the HRS course. I will email out the recording to anyone that wants it. I think it should automatically get emailed actually to all of you after it's posted. So it might be a slight delay to posting it, but you should get access to it. So I realize we went through a lot of things there, so it can be good to review. Yeah, and on our website, we should also have up now the SolidWorks Visualize course. So you can see the next availability for that. I believe it's either July or August. We have one scheduled online, yeah, in July. So it's a live course online with an instructor going through the SolidWorks training manual for Visualize. But yeah, thanks again everyone for attending. We'll email out those recording links. If you think of any other questions too, feel free to send me an email. My email address is ryan.n@hawkridgesys.com. Should be there in the GoToWebinar somewhere. Looks like if there's no more questions, we'll be shutting down the session here shortly. All right, thanks again, everyone.